Hello everyone, it's Paul with Tutor U, and today we're going to be talking about graphing quadratic equations. We're going to talk a little bit about parabolas, the general shapes of them, how they change. It's going to be a quick overview of just the general consensus on parabolas, and I'm going to try my best not to bore you with all of the crazy details, but I will say that some of the details are going to help you out considerably. But just stick around, watch the whole video, and I hope that I can help you out. If you like this content, if you like more educational content when it comes to math, and eventually I'll get into science, social studies, different topics, make sure you hit the like button, comment, or subscribe. I need to pull up the chat for everybody so I can see people commenting if they want to go on to different topics or whatever. I do have the general guideline of the class, but if you have questions yourself, make sure that you ask them, right? I mean, this is one of the best classrooms to ask questions in because nobody can see you. Don't be afraid to be wrong, right? But make sure you hit the like button, comment, subscribe. I would love to know that you're watching. I have had a couple of people participating in my classes, which that is an awesome experience. And let's get into the first part of class right after I pull up the chat. So where can my chat be? There is my chat. Okay, so I have it up over here, so I'll be looking over here when we're chatting, right? Let me adjust that, and there we go. So now we are ready to move into everybody's favorite part, math vocabulary, right? So above me, and I have a bonus even, right? Everybody loves math vocabulary so much that I've put a bonus math vocabulary question type of thing into our first go through with everything. So one of my rules, right, is to not slam everybody with a bunch of text, right? I don't want you to be up there reading all of this stuff and getting overloaded all at once. So I cover up the definitions, and then we can slowly reveal them like it's a magic trick or something, right? So we will go through our first definition, and that is a quadratic equation. If you've been watching my lives, we have reviewed quadratic equations, or kind of, it's more so with factoring. We've used the quadratic formula to solve quadratic equations, but let's just define it again for this video, because dealing with your parabolas, dealing with quadratics and graphing them, you should know the general idea of what is happening here. So let's go to our layer and let's start to erase. So they are equations set in the form ax squared plus bx minus c equals 0. So this is your form of a quadratic equation, okay? And what else is important there? It's where a does not equal 0. So your letter A cannot equal 0. Let's put a little line underneath there so we can make sure. So this letter here, oh, I'm not even writing on it. Huh, it's not working. Oh, that's because I'm still on eraser mode. There we go. So that A right there cannot equal 0. We do not want A to equal 0. All right? So quadratics. The definition of a quadratic equation: ax squared plus bx plus c equals 0, where a does not equal 0. That will give us a quadratic. It will give us a parabola, okay? Let's move on to our next definition of minimum. So you will get this whenever you're talking about quadratics and parabolas. You will be asked to find either the minimums or the maximums eventually, right? So what is the minimum? It is the lowest ordered pair of the given equation, okay? So your minimum is the lowest ordered pair of the given equation. And what do you suppose the maximum would be then with that definition? It's the highest ordered pair of the given equation. And if you remember, let's just make a little bit more room here. if you remember what is an ordered pair, right? What is an ordered pair? Let's just do a small note up above. So ordered pair. I think I can take, oh, here, let's do the bonus. Whoops, I just revealed it. So what is the quadratic equation? It is x equals minus b plus or minus the square root of b squared minus 4ac, all of that over 2a, right? That's a lot. That's a mouthful. Take a screenshot, you'll be fine, right? Don't worry too much. But let's talk a little bit about, let's talk a little bit more about our minimums and our maximums. So minimums, maximums, but mainly I just want to talk, if those of you that are watching haven't gone through ordered pairs, remember your ordered pair they are in parentheses. It's typically the x value first and then the y value, and then there are certain locations, right, on your grid. You can go, your x value is left and right, and your y value is up and down. So you have an ordered pair to tell you where you need to go. Okay. Welcome to the stream. I appreciate you watching. Everybody that is just hanging out and watching, that is always cool and awesome and greatly appreciated. So when I say the minimum value, the lowest ordered pair of the given equation, what we've covered in the past are just linear equations, right? So it's just a line. And if it goes on forever, there is no minimums or maximums. There is no low points or high points on a given line because it goes off into negative and positive infinity. So that should give you, and if you looked at the thumbnail, that should give you a clue that we're not dealing with things that are straight lines anymore. We are dealing with a shape called a parabola. So let's move on to our next slide. So I get rid of this. Hey, look at this. We're gonna be graphing some things. So I have a graph up, and then we have our x and y axis that we have labeled, right? Your x line is going horizontal, your y line is going vertical, and I have a few more layers. Hey, okay. So let's talk a little bit. Let's consider the following. Okay. So let's consider. I have it up. Let's just think about, is y equals x squared, is that a quadratic? Technically it is, right? If you remember the definition of the quadratic, it's just where a doesn't equal 0. It doesn't say anything about b or c. And so technically what this would be, if you were given this and you were like, oh, what am I supposed to do? What is this? Well, your a value here equals 1. What does your b value equal? Do you see a regular x by itself? It is 0. And then your c value in this quadratic is also 0. You just don't write those out, okay? But how do we graph this? Let's go ahead and do that, right? And just like any other equation, you will graph it, make a little table if you need to. It's very helpful. Oh, let's do a straighter line. Okay, so just like any other equation you're going to graph, your x values are going to be your inputs and your y values are going to be your outputs. So you will be putting a number in for the x, you get to pick, and then you get another number back out. Okay? And yesterday I had one of my students in here asking questions about why do I always pick the same 3 numbers? And I usually will unless I need to know more about the graph, but my favorite 3 numbers, and today we'll go a little bit more beyond that. So my favorite 3 numbers to pick for inputs are -1, 0, and +1. Okay? So we have -1, 0, and +1 that we're just going to throw into our equation, x squared equals y, or y equals x squared, whichever way you prefer, tomato or tomato. It doesn't change anything. So let's plug in 1, or let's plug in our -1. for this, and we will do more than this. So what happens when we plug in a -1 for x? Well, we get -1 squared, and -1 squared, y equals -1 squared. And what is -1 squared? That is +1. Okay? And then 0 times 0, 0 squared is 0. And then 1 squared again is also 1, right? So our first three points, they are at 0, 0. And then we can just say that this is 1. Let's not do that. Light color of green. It looks cool on the black, but not on the white. So we have 1, 2, 3, -1, -2, -3, 1, 2, 3, -1, -2, -3. Okay, so we have our grid system labeled. We're looking okay. Let me just check over. Okay, nobody in the chat yet, so that's good. Well, I mean, that's not good. I want you guys all to be participating, but it's okay. You can just hang out and lurk and listen and watch me do math if that's all you please to do. Okay, so let's finish graphing this. We'll go a little bit darker than that blue. So we have our first point of -1, 1, our first ordered pair. Let's see, ordered pairs. Ordered pairs. And our first one is -1, 1. Okay? So let's graph that. So we go -1, we go 1 to the left, and then 1 up. We are right here. And then we have 0, 0, which I've already plotted, and 1, 1, which is 1 to the right, and 1 up. So these are our 3 ordered pairs we are using. And graphing. And we will do a couple more just so you can see it. See what happens here. Okay, so let's pick another number. Let's just go with 2. Okay, let's go with 2. So what happens when we put 2 in for our graph, for our equation? We have y equals 2 squared. And what is 2 squared? That is 4. 2 times 2 is 4. So 2 squared is another way of writing 2 times 2. And so we have 4. So our next ordered pair will be 2, 4. So let's go over 2. So 1, 2, and then up 4. So 1, 2, 3, 4. Okay. What do you suppose the -2 would give us? When we graph, or when we have an input of -2 in our just y equals x squared problem, it will give us the point +4. Okay. And then really quick review. What are our quadrants? Just so I can hammer this into your head a little bit farther. This is top right is quadrant 1, top left is quadrant 2, down here, down bottom left of your graph is quadrant 3, and then bottom right is quadrant 4. Quadrant 4. There. And they like to label them with Roman numerals, of course. So let's graph this. We have 5 points. We can definitely graph this parabola. We will go with a nice blue. Okay, and it comes down and hits that point. And then it comes back up to 1, 1. And then it goes up to 2, 4. And look at that. Look at that. That is a nice looking parabola, in my opinion. You can tell I like my math when I'm like, oh, hey, I drew that. Okay. One of the funniest... Yeah. It is kind of interesting. And export. Think about places where this math is important, actually. There's actually a lot of places where this math applies. I mean, I don't know how much, I'm sure the YouTube algorithm is going to love me for talking about this, but like shooting guns, right? These parabolas can be any direction, right? So like let's just say hypothetically we have a parabola that's shaped like this, or actually let's make it a little bit more accurate. So we have something like, ooh, you have your curve coming down, and like when you think about it, if you shoot a bullet straight out, eventually it'll hit the ground, right? It's gonna curve. It's gonna have like that, it's gonna be really, really straight for a long time, barely coming down, and then boom, it hits the ground, right? And so like this type of math is used all over the place, I promise you. Oh, I even hit the microphone, I got too excited. Parabolas are all over the place mathematically. They're fun too, they are fun. You can make them move around, we're gonna go into that a little bit. You can shift them, move them up and down, move them left and right. It's cool. Yep, 0, 0 is your origin point. 0, 0 is your origin point. It is right here, right where I drew the pink dot. That is your origin, and that is 0, 0. Always start there. That's like your main reference point for everything, okay? And oddly enough, I want to make a couple of either maybe short videos or longer, fun, kind of not a GED topic, not a math, not a test topic at all, but a conversation about the number 0, because it is weird. It is the weirdest number out there, period. Plain and simple, right? Because you always have to have something first, right? When I was in college, our professor for my theoretical math class, they had us prove that that 1 existed, the number 1 existed. And the part that's really nice that he helped us out with is he gave us the first part, which is 0 exists. Like, so he already said, okay, 0 exists, now you have to prove 1 exists, and that stuff blows your mind. It's crazy. But we won't get into theoretical math here. Let's just talk about parabolas, right? Let's keep it simple. Although I will say, if you ever are interested, theoretical math is actually really neat. Okay, so we've graphed our first parabola. So let's go ahead, let's clear our first graph. So we will erase all of this. And I think I can just use the erase one on this. Okay. Yeah, it's fine. We can get rid of our numbers too for now. The main idea of the graph is still sticking around, but let's go back. Let's rewrite our problem that y equals x squared was our first parabola that we graphed. Now I want to add one thing, just so you can get an idea of like the manipulation, how you can change the way these graphs look. Because for me, that's where it really started to click, where graphing really started to like pop in my brain, and I'm like, oh, I get this. And it's where you can start to manipulate them. So y equals, what if we just change one thing? Let's just change the sign in front of the x squared and see what happens. So x squared. So y equals negative x squared, okay? So what's gonna happen when you have y equals negative x squared? Let's do our table. We have our xy table. Let's make a little bit more room. We have our xy table, and we'll stick to my favorite 3 points of -1, 0, 1, and then we'll even go up to, let's just go up to like 3 and -3. Okay, I'm gonna have troubles. I won't be able to graph the 3 and the -3, but just because of my size limitations, I'm still trying to figure out how to best stream this type of content. But what happens when we plug in? What happens when we plug in -1 for our x? Well, we get y equals negative sign, -1 squared. Okay. So what is -1? What is -1 times -1? It's a +1, but then it gets hit again, right? So you do this, you do what's inside of here first, right, with our squared value, the power of 2, and then you do, we'll do that in green, then you do this second part. And so what happens is that you get a negative number back out. You get, the answer to this would be negative, or would be a -1. 0 still stays 0 because 0 times anything is 0. So we can keep that as zeros. 1 also goes to -1. And then we'll do another example of 3. So let's write that one out. So what happens when we go y equals negative sign parentheses 3 squared? Well, you do your 3 times 3, which is 9, and then a negative sign. So y equals -9. -9. And then what happens when we do... Oh, I'm hiding it, I bet. I guarantee you my head is too big. Oh, I'm really close to hiding it. Let's see. Aha! If I would have kept going, if I would have wrote one more equation, it would have been behind my head. So, let's move on to, let's see. Yep. So, let's do our -3 value. So y, we'll do it over here to the right. So y equals negative, and then parentheses -3 squared. So -3 times -3 is +9, and then a -9 is your answer again. So if you're noticing, what do you notice export about this parabola? Well, it's still going to be graphed right there at 0, 0, and just for the sake of possibly being able to graph this, let's go, instead of counting by 1s, we'll count by 2s. So we'll have 2, 4, 6, 8, and then way out here is 10, and then -2, -4, -6, -8, -10 is out over there, -2, -4, -6, -8, 2, 4, 6, 8. Who do we appreciate? So, let's graph this in like this bluish purple. So we have -1 and -1 as our first point. So -1, it would be right there in the middle, and -1, so it would be right there. Right about there. And then 0, 0, we've graphed that. 1 to the right, which would be about right there, and then -1. Moving on, what do you suppose if we plugged in a -2 and a 2 for this, what would it be? It would be -4 and -4. So if we did this, it would be right here. If we actually found these ordered pairs, it'd be 2 and -4. And then lastly, our 3, which would be in between our -2 and -4, and then our +3 would be between our 2 and our 4, and that is way down here. So if this is 8, and then 9 would be like right about, we'll call it right there, and then right about there. Okay, and then when we graph this, we'll do that in a nice lighter blue, see how it turns out. It looks really good against the black. Oh, hey, it worked. But now, if you notice, our other parabola that we were graphing was open to the top. This one is open to the bottom. It's going downwards, right? So thinking back on the minimums and maximums that we were talking about in the definitions, does this graph have a minimum or a maximum? Right? I want export we'll see how long. I never change my my timing, my response time. I need to make it so it's faster response time. But would this graph have a minimum or a maximum? right? Is there a low point or a high point to this graph? Let's see. You got it. You've got it. And I think I have at least one other person hanging out, and you're more than welcome to answer it yourself. Minimum, maximums, right? Which one does this graph have? Okay. I'll give you a few more seconds just for the fact that I have a crazy long delay right now. I think it's like maybe a minute. Okay, so I'll tell you. I will tell you. I'll stop it. I'll stop the awkward asking of questions. So it is, this graph has a maximum, okay? It has this maximum, and it is right there at the vertex. The vertex, so the vertex is where things shift, it changes, right? So this is our maximum value inside of our equation of y equals x squared, okay? It has a maximum. When you have the parabola opening to the top, that's where you have a minimum, right? There's a bottom point. It's still going to be your vertex. So let's put that down as a note. In parabolas with quadratics, your vertex, so vertex, that will equal either your minimum or your maximum. Your vertex is either your minimum or your maximum. Okay, let me check something out. Okay, so it's also known, yeah, I just wanted to check. Yeah, so it's not your low point export, that is your high point, right? So when you have, so it's kind of like backwards talk. So when you have your parabola opening downwards, this right here, it has a high point. That's your highest point where it changes directions, right? There's nothing else above our 0, 0 in this graph. Nothing, absolute emptiness, right? And we can even, when you get deeper into math, I'm going to erase this after I do it, but if by some chance you go deep into math, you can actually start to figure out like what the area is. Oh, I can't do that many lines though. You can start to figure out what the area is like inside of this. So like think about that. So I can't remember the name of the musician, or like I don't know if he's a rapper or a singer or what, but back a little while ago there was a concert where a lot of people were hurt and they were squished, and what they've done to kind of try to figure out what happened, why that occurred, is they've made mathematical models. And like this right here kind of reminded me of the math models they made for that concert. And when you think about it, it's like, okay, we have these two walls. Let's just imagine that this blue parabola, there are two walls, and like this part right there is our like where our musician is, and you have all of these people inside of this amphitheater. Maybe it's the Red Rocks Amphitheater or something in Denver, Colorado, and you can start to figure out, okay, well, how much area is in this amphitheater? This is upper level math, right? You can start to figure out the density inside of this, right? You can do all types of cool, crazy, fun math, and like make math models to figure out what actually took place for any type of event. Really, it's cool. You change the shapes of your parabolas for different whatever walls. I mean, it might not be a parabola that you would use, but the same concepts apply. Math models where you create these boundary conditions and you can see what's happening. So kind of cool, very neat. So how is this? How is that minimum maximum? We'll do another change to this equation. So let's go through. Let's do that. Let's erase all of our stuff. And always, I mean, if you need to, go back and rewind this. That's the benefit of me doing it on YouTube, right? You can rewind if you need to. So these, I'll actually list out as we go through, like the different changes that we've done to our initial problem, okay? So our first part, our first problem, our first example of a parabola, of a quadratic that we did was y equals x squared, and then our second one was y equals negative x squared. But let's do y equals, instead of a negative x squared, let's go with 2x squared. So all of these are still quadratics, right? The a value of this quadratic equation does not equal 0. So doing the exact same thing of y equals, oops, let me make my point just a teeny, oh, that's really small, 10. There we go. So our x and our y values, and now we are doing our y equals 2x squared. When we have, you know, I don't want to use 1, 0 and 1 anymore. Negative 1, 0 and 1 anymore. Let's change it up. And I know when you're doing a test though, always stick to the same 3. You can just hammer through it super fast. Stick to the same 3 values, you'll work faster, and you will most likely still get the same answers. If you forget certain things, right? If you forget how to find your minimums and maximums, you can kind of just do the math equation. It might take a little bit longer, but you'll get the right answer. And I'll give you a formula here in a little bit. I just want to really make sure you understand the general concepts of what a quadratic equation looks like and how you can go about graphing it, right? And I hope this is helping. So what if we do negative 2, 2, 3, negative 3, and I still want to do 0 because that will in this example it will give us our 0, right? So then negative 2 times negative 2 is 4, and then times 2 is 8. We'll change up our colors. Y equals 2 negative 2 squared. Y equals 8. Boom, 8. What do you suppose the 2 will be then? Well, it will also be 8. 3, so what is 3 times 3? It's 9. And then times 2 is 18. We can't graph this one, I'm sorry guys. We can get an idea. We can get a general idea. And then 18 for our other one. But the big thing that this is going to do, okay, so we can kind of graph it. Let's just do a couple more points though. Let's do my 1 and 0 and negative 1. So if we plugged in negative 1 for that, so it's negative 1 for our x value. Negative 1 times negative 1 is 0. Times 2 is 2. So at negative 1, if this is negative 1 and this is positive 1, instead of it just going, and this is still 0, 0, instead of it going right here, so we have negative 1 and then 2 for our first ordered pair. Negative 1, 2, and then we would have positive 1, 2 for our second ordered pair. And then it goes into negative 2, 8. So negative 2, so if this was negative 2, then we would be probably way, oh, I can't even go up that high. It would be up above our graph. It'd be way up above our graph. I can kind of draw these points so you can get an idea. But what changed? I put that 2 in front of my x value. What do you suppose would happen if I put a 3 in front of my x value? Or a 4 or a 5, okay? So if I continue to increase that number in front of my x value, that looks too much like a V. It still kind of gets rounded off at the bottom. Boop. So if we continue to increase the a value in our quadratic, it will continue to get more steep. We will get steeper. We will continue to bring this in where it keeps skyrocketing upwards faster and faster, right? Pretty cool. Pretty neat. Let's not do that same color. Bam, something like that, right? And so as your a value increases, your parabola tightens up, right? And then you might ask, well, Paul, how does it widen out? If we can manipulate these things any way we want, so this, I will say, let's make a little note right here. It gets closer to our y-axis, so this is when, I don't have room up there. Okay, so this is when x is greater than, and greater than 1. Anytime you're bigger than 1, it starts to bring it in closer and closer and closer. And then, what do you suppose happens when you're less than 1, but greater than 0? Because we already did the example of when it was less than 0, right? When it was -1, it flipped your entire parabola upside down. It flipped it across the x-axis, right? Our horizontal line. So when you are between 1 and 0, it widens it. It makes it fat. It makes it big, right? It gets wider and wider and wider if you're between 0 and 1, right? So you could technically, I'll erase this part. So I'll do a nice green outer line here. So this is our base, or one of our base versions, but if we go way out here, you see this huge, big, fat parabola. Big and wide parabola, right? It is when x is between 1 and a 0. Or not x, when your a is between 1 and 0. Between 1 and 0. So decimals, your decimals, it makes it wide. It widens it out, it stretches it out, okay? Kind of cool, kind of neat, kind of neat. Let's get back. Hear my clicking on my keyboard. Control Z gets a lot of wear and tear with me. Okay, and I think I can erase from there, that point. So our 3 equations, 3 modifications that we've done. Cool. We're looking pretty good right now. How are you guys doing? I hope you're doing okay. I do have some example problems, some actual example problems that we can go through. And I want this to still be a summary. I could stretch this class out for hours. Hours and hours and hours. This stuff is basically its own field of mathematics, right? But I'm trying to decide what modification we should do next. What if we just go with, let's just stick to simple things. I don't want to go too crazy quite yet. Let's go with y equals, so our next one, so we've done these 3 already, but let's go with y equals x squared plus 1. That's just what happens when we do that, right? So we don't even have to graph this, right? Think about the problem. Think about it. When you plug in your input of 1, what happens? Well, it goes up a little bit more. When you plug in an input value of 2, it still goes up that same amount, right? And so it just barely widens. It barely makes it more steep. It's a little bit slower of the steepness, right? Kind of cool, kind of neat. And then what about 0 though? So it doesn't just make it more steep, it changes your entire center, right? So let's just go through x and y, And then if we go 0, 1, -1. So what happens when we plug in 0 here? So before, when we put the 0 into the 2x problem, it still was 0. Our center was still at the origin. But what happens when we plug in 0 for this problem? So what you get is it rises up above to a 1. So 0 squared is 0, plus 1 is 1. So our answer is 1. So our new starting point for this graph is at the ordered pair of 0, 1. Okay? And then our next point of 1, so 1 squared is 1, plus 1 is 2. So 1, 2. So then it would be 1 and then up 2. 2. And then our next ordered pair, -1, same rodeo, same show, 2. So we will be right there. And all it did when we did that plus 1 is it shifted our graph up 1. Is that okay? Right. Yeah. Your mins and maximums, your minimum and maximums, we're using the formula. Yeah. Yep. It's not too bad. This stuff, I love this stuff. This is actually, it can be a lot of fun. Good. So I will move on to the formula though. Like I feel like you get an idea, a general idea. If you just add a number, you're shifting your graph up and down. If your number in front of your x is between, or is 1 and above, it gets wider. If it's between 0 and 1, if it's 1 and above, it gets narrower. It makes it more steep. If it's between 0 and 1, it makes it more wide. If it's negative, it flips it down below, right? And then the same rules kind of apply there too, with how tight the parabola is. So let's go on to just a formula for our finding the x value of your quadratics, right? Like this is the x value of your mins and your maximums. Okay, so when you want to find the x value of your minimums and maximums, you use this problem, right? And if you remember that setup of your quadratic, so it is, oops, I'm not on the right slide. It is y, let's go with a little bit different of a color. The regular kind of outline for your quadratic is y equals ax squared plus bx plus c, right? And where a is not 0. Okay. So let's just make a quadratic up, and we can find the x values for the minimums and the maximums. So let's go with y equals 2x squared plus 3x plus c. And I asked you to find either the minimum or the maximum. Well, first off, will this have a minimum or a maximum? Check your sign of the number in front of your quadratic here. Check your sign of your a value. Okay? So, if that sign is positive, you will have a minimum value. So if a is positive, you will have a minimum. Okay? If a is positive, you will have a minimum. We will have a minimum. So then if it's negative, so the opposite is also true, so negative. And then we'll put some quotations, same type of deal. Negative, then you will have a maximum value. Okay? This is fun. This is I really love dealing with parabolas. I mean, I love all of math. It's quite enjoyable. It's therapeutic. It's relaxing for me. And I know that seems insane for some people, but I mean, after a while, it just becomes a little bit relaxing. You're just like, yeah, let's just chill out and do some math, right? So I want you to have our formula here for our x value. Oh, I didn't do it. I just realized, I'm like, oh, let's just skip this. So let's do this. Let's find the x value, right? So we have our equation. I'll do it below our graph, okay? So we have the equation. So our a value, oh, it's behind me. Our a value equals 2, our b value equals 3, and our c value equals 1. I didn't put a c value. Let's erase that. 1. Okay? So, what is the answer? What is the x values for this quadratic? Where the minimum is? And when you have that minimum and maximum, what's another way of thinking of that point? It's the vertex. That's where everything changes, right? It's either going to change at the minimum or the maximum when you're dealing with parabolas. When you're dealing with quadratics, that's the point. That's the point you need to have. It's super useful. You don't need to have it. It helps you out a ton, though. It helps you out a ton to have your vertex. You'll eventually find it, right? Because you'll be plugging in your values, and you'll notice that your y will start to go back up, right? Like if you were going from left to right, you're going down from left to right, and then eventually you'll start going back up. So you can find your minimums and maximums by doing that, right? It's just a tedious process. But plugging in our values, we have x, let's go with pink. We have x equals, and I think I have an okay amount of room. We will see soon. We have x equals, so negative b, so that's negative 3 all over 2a, and I'm down in the bottom right of the screen if you can't track this. I need to get a little highlighter thing for my cursor, or it puts that yellow sticker around it. Negative 3 all over 2a, so 2 times 2. So we have negative 3 all over 2 times 2. 2 times 2 is 4. So we have a negative 3 over 4. So that's the x value. That is what the x value is. And so we know, right, negative 3 over 4, that would be like right here. If this is 1, negative 1. So we know that our vertex lies somewhere on that line. It can be useful because if we just go through and start plugging in some points here, let me erase some of this. Let's erase our formula here. And I'm covering it up just a little bit. So I'll move this up. Okay. All right. So we have our equation. Let's just plug in a couple of points. Let's do 3 points on this, okay? We don't have to go crazy. 3 is a good number. And it will be, yep, you guessed it, export. It is y, x and y. And I'm gonna do my 0, 1, and negative 1, okay? So what happens when we plug in x? We plug in x equals 1. Question mark, x equals 1. So what we get, 2 times 1, so this is the other reason why I will always use 1, 0, 1, and negative 1, because you don't have to write anything down. Like, you'll be able to use this in your head, right? So 1 times 2 is 2. 1 times 3 is 3, so then we're at 5, and then 6. So our first ordered pair is 1, 6. If we did 0, this cancels out, and then we are left with a 1. And if we do a -1, it still ends up being 6. So this is kind of interesting. So we know that our vertex is right here on this line, this purple line that I drew out. But then if we plotted these points, or a general idea of these points, so we have 1 and 6. So 1, and then it would be 1, 2, 3, 4, 5, 6. Let's make these counting by 2s in our y-axis. So it's 2, 4, 6, and then it's still counting by 1s on our x-axis. I know that can confuse people, but I mean, it's your graph. You can do what you want with it, right? Like, that's the other part. As far as when I was in school, if I understood that you are the one in control of the whole equation and the graph, I think that would have helped me grasp these concepts a little bit faster. You can play around with all of these numbers, right? So your grid, when you change your grid system and the scale of your grid system, like how fast it moves up and down, you can manipulate the shape of your equations, right? And so that's kind of what we're doing here. I'm making a scaled down version of our equation just to fit it where it looks a little bit okay. So our first point is 1 and 6, so that's there. And then our next point is 0 and 1, so that would be right here. And then my next point is -1 and 6. Oh, something doesn't seem right here now. What happened? What happened? Or am I just a little tiny bit off? 1, 6. That all looks okay. -1, 6. I think my line here is not quite accurate. It's just going to make it look weird. So -1 and 6. -1 and 6, so it's right. Oops. It'd be right there. So somewhere, so this comes in, your parabola comes in, and it's somewhere in here. It's somewhere between our 0, our origin, and our -1 is our vertex, right? So we have our minimum value of x value of -3/4. We have our formula to find the x value of our minimum or maximum. I think we're doing okay with all of that, okay? Let's just check out an example question though. Let's get rid of all of this. Before I leave you today, I want to give you, you'll see a question like this on the GED, most likely. And I still use the GED as a good reference. I am going to be doing all different types of videos, right? My shorts have been blowing up lately, which that is awesome. If you like random math tricks and facts, check out my shorts. They're starting to get plenty of views, and I'm picking up more and more subscribers from that, so that's neat. So this is something, and export, we've done this already. You've already went through this. So we have our y equals x squared plus 2x minus 8 is our equation. And then it is find the x values for where the equation crosses the x-axis. And I say that with confidence that you've done this before because we were just factoring quadratics. It's the same deal. You do it. That's all you do is you factor this and you find your x values. So if we were to factor this, right? I want you to remember it's a binomial. You break this up into two pieces. So we have our two groups, our two parentheses. We'll just go with white on this one. Okay. What times what equals x squared? It is x and x. And then what are the factors of -8 that add together to a +2? Okay. So factors of -8. Factors of -8 that equals our factors of -8. That will be 4 times a -2 negative 4 times 2, 8 times negative 1, and negative 1 times 8. Okay, those are all of our factors. Which ones of these, when you add them together, equals a positive 2? It is 4 and negative 2. So it's plus 4 minus 2. Okay, we'll erase our factors of negative 8 just to save on space so I don't write over my own head again. So we have our factors, and then what you do to find where it crosses the x-axis, what is another way of saying this point on the line? I can't write on it. Dang it. Oh, I can write on it. So what is another way of saying like these points on the x-axis? What is your y? So if we are at x equals 1, but we're on the y, or we're on that x-axis, what's our y value? So x equals 1 in this example, right? I'm kind of going ADD moment, right? Like I want to make sure you understand this part of it. So x equals 1, and what is your y value at all of these points? What does y equal? What is the y's if we are all on the x-axis? The y values are 0. Your y values are 0, okay? So it's kind of cool. Kind of cool. So what do we do? Remember what we do over here? We set each one of these to 0. So we have x plus 4. Let's change it to that fancy blue or a green. X plus 4 equals 0. We changed our y to a 0. So where are we at? We are on the x-axis. So x plus 4 equals 0, and then we'll write our next one of x minus 2 equals 0. And then solve for your x. Subtract the 4 over. X equals negative 4. So add your 2 over. Inverse operations, add the 2 over. X equals 2. So at the points, so the points where this crosses, it's negative 4 for your x value and 0. And then you have x equals, oh, not x equals, then you have a 2 and another 0. Those are the 2 points. We know where this parabola crosses the x-axis now, okay? It's kind of cool. So like, then it's both points if you didn't notice. So let's just say that this is 2, 2, 4, 6. So that's negative 2, negative 4, negative 6. So at negative 4 and 0, and 2 and 0. So this is where the parabola comes in. Is it a positive or a negative number in front of your, or for your a value? It's positive, so it has a minimum, and it must come in something like this maybe. I'm just doing a very rough drawing. This is not accurate, but just to give you an idea, we might, someday with enough practice, right? So like our parabola could look something like that, and there we have it. We know where it crosses the x-axis. We at least know that. We know that it opens up positive. We can find the x value. We can find the x value of the minimum by using that formula earlier. You can manipulate whether it's going up or down. Tons of information in this video. And I think that we should do another day of working with these, just because like my 1 hour is almost up, and I don't want to just like try to skip over quadratics easily. It is a very intense, but for those of you that are coming in for the GED type of thing, that you don't like, you have to have a pretty good idea of how to factor and how to solve these types of problems. Graphing is not, GED, it's not intense when it comes to graphing, okay? You might put some points on your graph, and that's about it. it's not very intense on the graphs per se, right? Like under normal conditions, they do have random tests, right, on your GED. So like every time you go in there, it will be a different test, or it's like one of like 10 tests that you might get. And so like there might be one that has a little bit more emphasis with graphing, but to my knowledge, there's not a ton of graphing. Solving what we just did here, that is, you need to be able to do that, okay? That's important. But we will call it good there. If you liked this video, please make sure you hit the like button, comment, and subscribe, because those things help this channel get thrown out into their algorithm, like export yesterday. And so yeah, I'm gonna call it right now. Tomorrow we're gonna do more with quadratics and parabolas, okay? So that is what we will be doing tomorrow. But just to give you an example export of you like participating, being active in the class, my shorts, my video, one of the shorts that I posted yesterday while we were going live, it got almost 1,000 views in our class because you were typing into the chat, right? So that is pretty cool. For a 10-second video, I got like 4 hours of watch time because of it, which is nuts when you think about it. Oh, question. Is it always important to use 0 to find the points? Yes. Yes, so you have to set it, you always want to set it equal to 0, because that is where, so when your y is 0, where are you located at? If I give you any ordered pair, if I just say x, so here's our ordered pair, can you tell me where you are located? Where are we? Where are we? My ordered pair is any number, and then we have a 0 for our y value. Where are we located at? And you should be able to tell me, hey Paul, we're on the x-axis. We're crossing, we are at that point. We are at the boundary of the x-axis. It does not matter where we are at. Like, in a sense, this is the graph of your x-axis. When I say something like this ordered pair, I'm saying any, maybe all numbers, all real numbers, so x equals all real numbers, right? That would be your graph for your x-axis, right? And then same thing, if we flipped it around and I said your x is 0, so you're not moving left or right at all, and your y, I think this is fitting, probably not. If we said, I'll put it, I think I can put it right here. If we said y equals all real numbers, and then we went ahead and we said your x value is 0 and your y value can be any y value, boom, there's the graph for our vertical line. That's what will make it go up and down infinitely. So so you can make an absolutely true statement. You can say, whenever your y is 0, you are located on the x-axis. Whenever your x is 0, you are located on the y-axis. Okay? So I'll tell you, my favorite part about math is the absoluteness of certain things, right? So it does not matter, right? When I say the ordered pair of, here, I'll just show you just kind of a weird thing. I find it kind of cool. But, so like, the amount of knowledge and knowing truths, absolute truths, when you come with math, when you get deeper into it and everything, that really took a long time. So, let's just say I gave you this ordered pair of, we have negative 1, 2, 3, 4, 5, 6, 7, 8. Doop, doop. So we are at the ordered pair of negative 12,345,658, and our y value is 0. Well, guess where we're at? We are way to the left of our origin, but we are still on our x value, our x-axis, right? Like, we've moved far to the left, but we didn't move up or down at all. So you're still on the x-axis. Like, we have a way to clearly define every single point. I almost knocked so many things off of my desk with that swoop. Here, I'll leave you with a riddle. I want to leave you with a riddle today. Not a riddle, but it's a logic. It's a logic statement. Okay? I can't delete things fast like that. Let's just clear this all out. So, is this true or false? Okay, so that's the question. True or false? This is technically math related. It's not going to sound math related, but think of it as like a theoretical math question. Every human taller than 10 feet has an IQ of 1 to 1,000. Let's just hang on. Let me make this at 12. Let's go with 12 feet. I'm not sure. Hang on. Let's go with 12 feet. Every human taller than 12 feet. That might be a hint, but every human taller than 12 feet has an IQ of 12 or of 1,000. Is that true or false? That's your math, a little bit of a logic question for you. So is that true or false? And I will leave you with that. If you like this content, hit the like button, comment, subscribe. I appreciate you. I hope you have a beautiful day. We're going to do more stuff with quadratics tomorrow. I know it's everybody's favorite topic, but I will talk to you later. I appreciate you, and have a beautiful day. Whether it's cold, hot, rainy, whatever. It's a beautiful day. Take it easy.